Okay, I think we can start now. So, hello everyone, welcome to the DLP live session. This is for the vision module. So, today we will be covering the portions which were discussed in week 9, that is for object classification, and also for week 10, that is for object detection. And I'm pretty sure that you guys have already done the Kaggle competition for object classification. So this is quite similar to that, and we will be testing out different kinds of models. And this is going to be a interactive session. So I will request all of you to provide any suggestions or any kind of code modules or different kind of things which you want to see in this data set. Okay, let me share my screen. Okay. Uh, and yeah, please stop me if you want to just unmute yourself, and if you have to ask anything you can just stop me over there. I think it's visible. The screen is visible. Yeah. So now we will be discussing some of the topics related to object classification, and for that we will be looking into one of the popular data set, that is the CFAR 10 data set. So I have opened that page for the dataset, so you can see over there. So there are 10 classes. There are some 60,000 images, 32 plus 32 color images in 10 classes, and with 6,000 images per classes. So this is the CFAR 10 dataset, and similarly there is also one more datasets in the CFAR, which is called CFAR 100 dataset. But now we will be only looking into the CFAR 10 dataset, and these are the classes. As you can see, there is something: aeroplane, automobile, bird, cat, deer, dog, frog, whatever. Okay, yeah. So again we will be going using the torch modules. Okay, part is not. Yeah, so these are the important libraries: PyTorch libraries, transform models, data loader, and all. And okay, let me just restart this session first. Okay, it is not started. Okay. And as you can see, I have changed the runtime to some this T4 GPU. This is, I think, A100 GPU, and this L4 GPUs are only available for the Colab Pro. So they are not allowing me to use this GPU. So I will be using only this T4 GPU. Okay. So yeah, it will take some time. Okay, this has downloaded, and now we will be selecting the device over here. So this is just to change it to GPU. And yeah, just this part is not important. And yeah, so these are the some of the hyperparameters which we'll be using. So these are the name of the variables. I think you all know this is the number of epochs, the number of iteration for which we want to train our models. Here I have kept it is as 5. The batch size, this is 16. Now we can change it to something 32, 64, 128, like that. And the learning rate, as you know, that we are trying to optimize a loss function. So for that we need something as a learning rate. Here I have kept it as 0.001. And here we can change it to some other epochs values. For this live session I kept 5. Anyone who wants to change this epochs, any other value? Yes or no? Anyone? Fine. Okay, so this is the batch size. As I said, batch size can be increased or decreased. So the and this is the transform function. We will be normalizing the photos from zero point 0.5 to zero point 0.5, and these are the data set train. And okay, let me just run this first. Okay, so this is just downloading. So torch division dataset already has the CIFAR 10 dataset, so I'm just downloading it from there. And as you can see, it has already downloaded. Now what we are going to do is that we are going to visualize this data. So yeah, so this error which we are getting over here, it's just because we are also normalizing this pictures. So if we remove this function over there, then we this kind of warnings will also be removed. Now the CIFAR dataset, as it is not of so much high pixel value, so that's why you are getting a photo like this over here. So as you can see, there is cat, there is ship, this aeroplane, frog, some random photos have been picked and it has been plotted over here. Okay, now the first thing which we are going to do is that we are going to first train a customized simple CNN model, which will be specifying the convolution layers, how the convolution things works at normal. You can consider it as a scratch model, and then we will be looking into the different models which are already available. I'm pretty sure you have gone through the different models and also have used that in your Kaggle competition. Okay, fine. uh, so as you can see, this is the class for the simple CNN model. And yeah, so this is the convolution layers so here I have kept as the two convolution layers are there. And this is fc1. Fc1 means this linear layer, this is fc2, this is the second linear layer, this is the pool function. I am performing a max pool over here. So yeah, anybody wants to volunteer and say what is max pool?
It is
Sir,
one of
out
the
of
features.
all the 4 pixels, it will choose the maximum value.
Okay, out of the 4 pixels.
Out of the size of the max pooling thing. Like if the size of the max pooling is 3 by 3, it choose from 9.
So
If
what is the
size is two by
max
two,
pooling layer size over here?
uh, here the size of the max pooling is 2D, so 2 x 2.
2 cross 2 and 2 cross 2. So what will happen for a 2 cross 2 max pool layer? So suppose
It
I
will
have,
it will
yes,
select the max value out of the four value of the kernels.
okay. A- and what is this tried equals to 2 does for this code?
It shifts the pooling from let's say from the leftmost to 2 and 2 and 2. Similarly, from topmost to bottom side.
Okay, fine. Okay, yeah, so this is the simple CNN model as you have seen. So this is just make, you have to make sure that these numbers are like constant, like correlate to each other, otherwise there will be some issues over there, because there's some kind of matrix operations happens over there, right? And here I have kept it as 10, the final layer, because there are 10 classes. And now we will be training this model. These are some simple codes just to for training this model. Those who have done deep learning, they might know this is just some optimization function is there, loss function is there, and all. Okay, fine. Let's run this, and we will be also seeing the error values. And as previously I said that the epochs values I have kept it as 5. The batch size is 16. We can also increase it to some. Okay, for now let me increase it to 128. Fine. Okay, so these are some of the, this what they call this, this is the class over there. And yeah, now we will be running this, training this model. So here the optimizer is Adam, and the learning rate which we have chosen as 0.001, 0.001. Okay, so as you can see, this loss is coming up. Yes, the accuracy, as you can see, it's 71.05%. So that's the last line, that is the evaluate model, the simple CNN model, and this is the test loader. As this is the test loader, so basically it contains the test data set, and the performance on this test data set, it gives around 71.05%. All right. Uh, so this is just a scratch a simple CNN model, and you can of course change the number of layers over here, play with the max pool 2D over here, and stride everything, and see the different kind of accuracy which you can obtain over here. In fact, you can also check if you have the, if you decrease the batch size, what will be uh, what can happen with this this CNN model. So this, remember, it was 71.05% over here. And now we will see what happens. Yeah, so the accuracy has increased a little bit, 71.43%. Okay, so this is a normal scratch CNN model, and now we will be using different other models which are already pretty established. Uh, we will be using some pre-trained model. So we will also be seeing what will happen if we don't do a pre-training over there. And so some of you have used, I think, in the this Kaggle competition, some transfer learning. So yeah, anybody wants to say what is this transfer learning?
So transfer learning is directly using the same model which is already been available without using any fine tuning. We are transferring the same knowledge to our own data set to
Uh,
predict the something.
so how are you transferring the knowledge if you have just a model? So
So basically, what happens? Let's say if there is already a pre-trained model available, we know that it has been trained with something, and it has some weights. So
Mm,
that
yeah.
weights is now will be available to the next model or the things we are predicting on, and using that weights, it predicts us our output.
So basically, you are just fine tuning the weights for your customized own problem task, right?
Right.
Okay. And any idea like what's one of the common data set in which most of these architectures are trained?
No idea.
Okay, it's ImageNet, one of the pretty common data set. So yeah, I can just show you. So yeah, most of the models are trained using this ImageNet data set. So as you can see here, so here we have used this load equals to pre-trained model name. Okay, we will be going to this part later, and first we will be discussing these things. So for this session, I have chosen this VGG16, ResNet 15, efficient net B0, and the last one is this mobile net V2. And we'll be seeing everything, each model, what is the accuracy and everything. But the thing which determines whether this model which we are currently being used is pre-trained or not, or we are performing any kind of transfer learning is based on this thing. So pre-trained equals to true. This is a Boolean parameter which specifies that we are using a trained model, and if it is false, it means that we are training, we have the model, we have the what kind scratch model, you can say. We have the complete model, but there are no weights over there, or you can say it's not trained. So we have to train those that model completely from scratch. Okay, and I think you guys already know VGG16, ResNet 50. So these two models are new, I think, efficient net B0 and mobile net B2. So we can see this V0 architecture. These are mostly these are mainly used for this embedded systems, which no, for the low end systems. This efficient V0 general architecture. So okay, let me open the picture. Is it picture visible? Okay. And this is the mobile V2 net. So mobile V2 net, this names already can like give you an intuition that these models are built for some kind of low end devices, right? And this is for mobile V2 net. And yeah, let me just search this. So yeah, here you can see some architectures over here. We'll not go through the architectures, we'll just so we will just be seeing the performance of these models on this data set, and we will also be seeing this what will be the performance change if we are not using any kind of transfer learning over there. Okay, all right. So yeah, first let's see if we are not using any kind of transfer learning, so what will happen over there. So we have specified all this as false. Remember, the number of epochs which was chosen is 15, and the batch size is 16. And yeah, and these are the this is a I'm training this model in the form of a for loop. So I will be passing this model names in this function. So what I can do is that I can just write all these names over there so that it runs in a loop. think this. Okay. So the first model which we will be training from scratch. Now we will be training it from scratch since we have specified it as pre-trained equals to false. The first model which we will be training is VGG16. Any question till this far? So as you can see, the training has started. So it will train for 5 epochs, and the first loss is something 2.3087, and this is for VGC60. And remember, we are training it from scratch. We are not using any kind of transfer learning over there. So meanwhile, these trains. So for the week 9, this Kaggle competition. So what kind of models you have used? Avinit Raman.
So for week 9 object recognition, I used VIT model from Google, the base model of that. First, I tried VG16. Then I read about that there's a variations of VG model, which is VG19 and so on. And there is also batch normalization thing. So I tried that.
Hmm.
Then I found that transformer architecture has better accuracy as compared to uh, PyTorch modules. So I tried transformer model, and then I found that VIT is the similar comparison to VGGNet. So I shifted to that and tried and got a better accuracy.
What was the accuracy?
So my F1 like metric was the F1 score. So I backtracked based on that, and
Hmm.
it went
Yeah,
around
F1 was
0.88.
hmm, okay. And Jalaj Trivedi.
Yeah, sir. I initially used ResNet.
Hmm.
I used, I fine tuned the fourth layer and I also fine tuned all the layers, but it was overfitting. The maximum I can score with ResNet was like 85. So then I went to efficient net. I
Hmm.
tried B0, B1, B2, B3, B4, and I get on till B7, I think.
Hmm.
So B7 is a very large model. I think Kaggle GPU cannot handle B7. So I reduced the batch size and made it to 8. But still, I wouldn't get a good accuracy. I would say got around 94-95% using B7.
Okay. M Nagarajan. Okay. Chaitanya. Okay. Tried. Okay. Pritam.
I used AlexNet and ResNet 50.
Okay. Puneet.
Hello, sir. Good evening.
Good evening. Good evening.
Yeah. So the first one was obviously the CNN. I
Hmm.
tried to follow the lecture and try to do something there. It
Hmm.
worked. Not a very good score, but very good. I mean, decent for a CNN first time.
Hmm.
Then I set up a loop to try different models and different learning rates.
Hmm.
And so there I had ResNet 1850,
Hmm.
VGG, VIT.
Hmm.
And I think the highest score I got for submission was through the VIT.
Okay.
But they were all in the same, more or less same range between 0.92 to 0.94.
Okay. So when you are saying that you are trying all these things in a loop, so did you use any other modules like this, weights and biases?
Yes, in fact, I did on my local laptop. I did not on the Kaggle one.
Hmm.
In fact, I will have something to show. Maybe I'll put it on Discourse. I found my old 30-year-old code on image classification. It was
Oh,
written in Turbo Pascal.
okay.
So it used to, we had done it to again identify images in the 90s. So
Mm-hmm.
we even pulled that out. Maybe some students might be interested in
Yeah,
looking
yeah,
at old school. Looks
yeah,
like.
yeah. Sure, sure.
Right.
Yeah, yeah. Please share that then in the
Yeah, I'll
discussion.
do that. Right, I'll do that.
And who else is this? Archit Handa.
Yeah, I of course started with the CNN.
Hmm.
Was not that good of a score, so I went with the ResNet 50. I fine tuned just the. I added a linear layer at the end and a batch normalization plus dropout plus yeah
Hmm.
blue, and then finally the classifier head. Fine tuned just the head. I think I
Hmm.
got 0.85 with that, something like that. And then I tried the same with Resident 152. Still didn't increase that much, so I switched to a Swin transformer based model,
Hmm.
and again applied that classifier head, and I think I got 0.94 with that. Yeah.
But one thing, Archit, what was the team name you have given in the Kaggle competition?
My roll number.
I saw your name only over there.
No, what I did, actually, my 30 hours got consumed. So what I did, I logged in with my personal account and just
Mm.
wanted to train the models with that. And then whichever model was the best, I switched it to my IIT account and I ran it
Okay,
finally with that.
okay. And who else is there? Piyush Agarwal. I think he just joined now. Okay.
Yeah, sorry, I'm not aware what we're discussing.
Uh, your voice is feeble. Can you speak a little bit loud?
Yeah, I said I just joined, so I'm not aware what we are discussing.
Okay. Yeah. Do you know what you are discussing today in this live session?
No, sorry.
Okay. Yeah. So basically, we are discussing the week 9 and week 10 modules, and yeah, we have already gone through a simple CNN architecture, and now we are training different CNN models in the form of a loop.
Okay.
Okay. So I was asking that what was the model name and what was the accuracy you have got into this week 9 Kaggle competition.
Yeah, I got around 0.88, I think.
And what was the model you have used?
Initially, I was using ResNet, I think. Then I switched to Vision Transformer. I didn't experiment much, just ran a few submissions and I was satisfied with the score, so left it there only.
Okay. Okay. Fine. Okay. Let's switch back to this notebook. So as you can see, it is not improving much. This VGG 16, right? So yeah, and it's also taking a huge amount of time. So okay, now this is just VGG 16, but I think this RESTnet 5 and efficient V0 and MobileNet V2 will be fast as compared to this VGG 16. Okay, so you can see this loss values are swinging in between this 3028 and 3029. It's just some kind of swing is happening over there. The last epoch. So what was I was saying is that, so if you want to tune any kind of hyperparameter, if you want to see this how this different kind of modules work, so for that what you can use is that this something called as weight and biases. Anyone has heard about that?
Yes, sir, we have used it before.
Okay, you have. Oh, this for the deep learning courses, right?
Yes, sir.
Yeah.
Right.
Okay.
So while this is going on, any suggestion for tuning after it plateaus? In most of my models, after the fifth or sixth epoch, it used to plateau.
Plateau means it is some kind of value. This is stagnant, right?
Yeah, it gets stagnant, comes down, but remains in a range bound.
Yeah, yeah. It's mean just what is happening over here, like it's swinging in some
Right.
range, right?
Exactly.
Yeah. So what it might happen is that it's not reaching some kind of global minima, right? So for that, what you can do is that you can try to change this learning rate over there.
Right.
Like what will happen is that, so if you have, so just follow this mouse curve, okay, right? So if you have something like this, right, but the
Mm-hmm.
function is some kind of a huge kind of curve, and you have reached some kind of local minima instead of the global minima, and you need some kind of push to cross that boundary.
Right. So,
So for that boundary, what you can use, that you can increase this learning learning rate over
Decrease
here.
it.
Yeah,
Decrease it. Right.
not decrease. I'm saying that you can bit increase over there at that time. So
Oh,
what is happening is that this is the plateau you are saying, right? And you want to reach over here if you are
right.
following my mouse, right? So so to cross this value over here, you need some kind of push.
No, okay, no, I meant that it's not going to a higher accuracy or a higher F1 score beyond a certain point.
Yeah, yeah. So that's why I'm saying that it's not reaching over here as compared to this
Okay.
part. So
Okay.
for that, you need a push to cross this boundary over there.
Right.
Hmm.
So, any recommendation? I found whole lot of methods now to identify that after a few epochs, if it doesn't improve, it'll automatically stop.
Yeah,
Or
that happens because this thing is so you can use this something as adaptive this learning rate also over
right, I
the
tried that. Yes, I did see that. There's a cosine one and there's another one, adaptive one.
cosine adaptive learning rate also you can
Right.
see.
Yeah, there are multiple schedulers also, like cosine
Yeah,
and scaling.
exactly.
Mhm.
Mm-hmm.
All those things you can check. And if you want to go little bit to the mathematical foundation, like how why these things happens over there, so you can check this things called as convex optimization courses.
Okay.
Over there you will be finding out that how this loss functions, these things propagates over there, and what I mean this by value, local minima, local maxima, and this global minima, global maxima.
Okay.
Yeah.
All right. I do have one more question. So while
Yes.
this, I was trying to run multiple models, right?
Mm-hmm.
So there is, if you Google immediately, the one of the first recommendations that come is pi caret, caret,
Pi e
caret, that caret,
r e t.
et, yes. So this one you can actually code it to try different models and different parameter values, ranges.
Hmm.
So it simplifies your coding a lot.
Okay. Oh, I have no idea about this.
Okay, all right. So yeah, I found this. I thought this is something worth sharing.
Okay.
It really simplified the architecture.
So what it does is that it has some kind of models, and you are just putting some kind of hyperparameters over there. Like you are
So
not.
right, it is built for comparing and finding out your best model.
Okay.
Among like what we do hyperparameter training, this is
Hmm.
for hypermodel training. Some
Okay.
lack of better words.
Okay. Okay. Yeah. This is, I think, new.
It's
I
quite interesting though. Yes.
low code and open source library in Python. Okay. Yeah, they have made some videos also.
Mm-hmm. A lot of good documentation now for the new
Hmm.
models. Right.
Hmm. Nice. We can try this out. Dots. Banana by character. Build open source.
So I was trying to look for things that will run unattended.
Mm-hmm.
So like
Yeah, yeah,
bed or office, it keeps running in the background. So I was looking
mm.
for things like that, solutions for like that.
Yeah. This switches off if you have if
Right.
something. Yeah, if it's kept idle for a long time, it switches off.
Mm-hmm.
Anyway, so this is the issue. I think this is taking a huge amount of time. Anyway, so basically you can see this is something accuracy we are getting as 10%, and ResNet 50 also maybe we will get around 50 or 60% over there. But the accuracy will increase if we increase this pre-trained. This thing is equals to true. So for that, it will with the less number of epochs, it will provide a fairly reasonable accuracy. Okay, yeah, I will not be covering this part. So okay, anyway, I will be sharing this code with you all. Maybe we can what we can do is that we can just use one of this module instead of the all this module and just check for that. right? So we'll just checking this mobile net v2.
I have a question.
Yes.
While training for the GA, what I did was I transformed the data with using multiple those like brightness and rotation and everything,
Mm-hmm.
and I combined that transformed images with the original images, and then tried training
Mm-hmm.
on that entire set. But in that case, the model started to overfit. To my surprise,
It
uh,
shouldn't happen.
yeah, that is why I was wondering why that was happening, and then I just switched to normal with the transformed images only, and then um, it was not overfitting that much.
Overfitting as in which for the public data set, public scoreboard, right?
No, not in the public one. I had so we had the train data set, yeah, right. So I split
Yeah.
it into a validation and a train data
Okay,
set.
okay, okay, okay.
And for the train one, I applied all those transformations, combined, augmented it with the original data set, and then I was
Mm.
training it. And
Mm.
for validation, I was getting 0.94, but for training, I was getting 0.99. But when I just went with only the transformed images in the training data set, then it was 0.94 for both.
Yeah, it may happen because of this diversity of this data set. That may also happen. May increase this. It may happen there is not so much diversified images, and it is not providing any kind of positive impact to this model. If when you are doing some kind of this, what is this term, technical term? So transformation and all.
Data
Do-
augmentation.
Data augmentation, right? Data augmentation. So basically, what will happen is that we are increasing the diversified data set, right, by using this data
Correct.
augmentation.
Correct.
Mm.
Also, like in this case, we were just fine tuning these or transfer learning.
Mhm.
What if we have to develop a model on our own? So, like VGC has 16, then 19, then ResNet goes bonkers with 50 and 152 layers. So, when do we realize that okay, this is a good place to stop with the number of layers, or uh, what layer to add when?
So this there is no complete answer for this, like when to stop and when to start. My means when to go further beyond this CNN layers, right? And I would say it depends upon your application, what kind of application which you are using, right? And yeah, so there is some intuition, like people say that the deeper you get, the deeper models you have, the accuracy will increase, but sometimes it gets saturated. Okay, so it mostly is on, I can say it's on the performance this application part, right? And yeah, and there are certain other things also which I, since you pointed it out, so uh, sometimes what we happen is that we have a huge network, right? Suppose some 15, 16 layers, but will be some thousand, 10,000 some weights over there, but we don't need so many weights, means those weights are completely uh, zeros, like that means they are not giving any kind of have some contribution over to this model. So at those times what will happen is that it increases the memory consumption and all these things of this model. So what we can do is that this is something term is known as the pruning of this deep learning model. So that's also a active research area. I think you can go look into that part. So what will happen is that you are pruning these models, means you are just cutting out this branches, these weight branches over there, and then again you are training. So you are using removing the redundant weights from those models. Again, that's also for the application part. Okay. So there is so when you said this, so there is a famous this video lectures by this MIT. So when they are doing this some kind of pruning, right? So she has made a pretty good video over there. So what happens is that this video captioning, right? So you have some kind of videos, and the task of that model is to evaluate that sorry, the not video, it's some kind of image, and to provide a caption like some soccer game is happening. Okay, these two teams are playing over there like that. Now when they are pruning this model, sometimes this accuracy also decreases. So the first they are saying this Argentina versus Brazil, this game is happening. Now they when the model has pruned enough, so they are saying that that model is saying that there is some soccer game is happening between this blue and green team. Again, when you are more pruning that layer, those the neural network, so what will happen, it is providing some kind of result as people are running inside in the playground. Now this is mostly for the application dependence. For some people, just soccer game is happening, that kind of information is enough. For some people, no, they need a proper description of which team is playing to against which team, like that. Okay, fine. So yeah, you can see this is the accuracy which we have obtained. So we have trained this model from scratch, and we have obtained something like 65.09% percentage this accuracy. Oh, let me just copy this section. These things are not okay. So now what we can do is that we can just here we can just specify what is this called pre-trained model. Now we are keeping it as true. We'll be using some kind of pre-trained model now. Okay, it started. Now just see the comparison of this error loss, right? When we are using a pre-trained model, the loss is the starting loss is something as 1.3552, which was previously 1.9534. Now we will also see that the accuracy will also increase because of that. Yes.
So what about loss functions? I found a new loss function called focal loss that helped to improve. I've submitted that. Any suggestions from your side?
I have used only cross entropy. Focal loss. Focal loss. I have no idea about that.
Even I didn't know about it. So it was recommended for images, classification of images.
Focal loss.
Yes, sir. If you look at my notebook, I've submitted that. In my README also I mentioned that.
Hmm.
This got me a bump up in my training.
Applies a modulating term to the cross entropy loss in order to focus learning on hard misclassified examples. Okay. I think it's pretty new one. Like it's
Yeah, it's new.
some kind,
We didn't study this. It just found it. Right.
and it's some kind of addition over to the existing cross entropy loss. Yeah.
Yes. Yes. So the class imbalance, there are a lot of methods, there are a lot of libraries that
Mm.
handle class imbalance.
Mm.
So loss was one of those categories. But how to address it?
Okay, so this paper is from 2018,
Mm-hmm.
submitted 2017, and it was last revised. What was from 2018. Yeah.
There's one more paper, so not there's one more by different author. This is different. So anything from your side, will the loss function make a big difference?
Yeah, loss function will make a difference, right? So which kind of loss function what we call this you are optimizing on, that will play an important factor, right?
Okay. But cross entropy is the base for image classification.
Yes.
Okay.
So it is adding some kind of hyperparameter over there to
Yeah.
reduce the chances of this misclassification, I think.
Right. It just keeps a running score,
Hmm.
and at a certain threshold, it will reset to a certain lower value. So
It's not just a generalized cross entropy.
no,
Hmm.
this is specialized for certain cases.
Okay, got it. Yeah,
We'll,
that's a good thing about this competitions and all. Na? Do you get to explore different kind of modules over there?
this has been one of my fun courses in the degree level.
Oh,
So I like this, a very hands-on approach.
mhm.
If I only knew how to convert this to quiz score,
Hmm.
you
Which?
know, my scores don't speak for that all the learning I've done.
Yeah, yeah, yeah.
The
Hmm.
quiz scores don't match that. So,
Hmm. Okay. Yeah. So as you can see, right, the accuracy has increased a little bit for the same 5 epochs. It's not. It may not seem a huge difference, but like actually for a huge kind of data set and for different kind of application, this can play an important factor. 65 to 69, 69.80. It's nearly around 70%. Okay. And similarly for different when you are training with this ResNet and all these models, if you again change these things to this pre-trained equals to true, means if you are using a pre-trained model, then the accuracy will may increase. And the last thing which over there I was saying is that this classifier model dot classifier, so it is, so at the end we have to specify the number of classes and all, right, for our tweaking the part for our own classification model. So for that you can check which of the classify this. Okay, let me go over like this. So which layer do we need to tweak so that it can be modulated for our own problem? So for that we may not remember everything right at that time, so that for that we can just check this model dot classifier over there, over here. So here this linear layer is at this one, and if we, instead of efficient vnet, we can uh, check something else like the VGG16. Okay, VGG16. So VGG16. So as you can see, these are the linear layers over there, and we in this model we were just changing this sixth part. So it is addressed as 0 indexing. So it means that the seventh layer we are uh, changing a little bit so that it can be modulated for our own classification problem. Okay. Okay. Any question till this far? Okay. So yeah, this was mostly what was covered in the week 9, the CNN models over there, and now we will be moving to the other part of this live session, that is week 10, object detection. So for object detection, so the lectures cover fast, slower RCNN, fast RCNN, and faster RCNN. But for now, we will be covering which the most prominent one, that is the YOLO V8 model over here. Okay, and yeah, so we will be using a data set. Some animal data set is there, and yeah, I have downloaded that in my drive. And as you can see, okay, so this image is up there. So I downloaded this images from RoboFlow. So from RoboFlow, you can like see there are pretty much different kind of data sets available over there. Also, I think Clipchamp is also there. From there also you can download different kind of data set. So yeah, this is some of data sets are there. Some fox data set is there. There are different foxes, and not only fox, some other animals are also there downwards if we go a little bit. Yeah. So it is something as a serial order they have saved it. Okay. Yeah. Okay. So first I have to mount this on my Google Drive to access the data set. Okay, too many sessions, so I have to disconnect the previous session, otherwise it won't work. Okay. Now I have to give permission to access my Google Drive. Okay. Okay, the Google Drive has been mounted, and now we will be specifying the directory which contains this data set. And now we will be installing this Ultralytics. So this is the Ultralytics. This contains actually all this kind of YOLO models over there. So for that we will be installing Ultralytics, and this command, as you can see, it's pretty much like if you have used Ubuntu, you will know that these cells can be executed in a terminal mode by using this exclamation mark. Okay. Yeah, so it is downloading all these stuffs. Okay, just downloaded, and now we'll be installing YOLO. So importing YOLO, not installing. We have already installed alternatives, so we will be importing YOLO from there. Okay, and this is the model which we will be using over here. So YOLO V8 model, and these are the trained model over here, and this is the data.yaml contains. Okay, just let me open that file. So it contains the different classes over there, and it also contains like the path for the train, validation, and test data set. And here, as you can see, there are 10 classes over there: some cat, chicken, cow, dog, fox, goat, horse, person, a raccoon, and a skunk. And this is just a license for the of the overflow. So yeah, it can, you can say it's some kind of map for that model. So from where you are going to execute the train uh, data set, validation data set, and how many classes are there, and all those things. So as I said, I will be using pre-trained model. So epochs I have kept here as 20. So anybody wants to change this, or we can change it to something 10. Maybe we can just change it to 10 and then see what happens. Okay, let me just run this model. So we are using a trained YOLO V8 model. Oh, what? So as you can see here, it is written images size 640, trained 640, validation. All these things are there. Yeah, it has started.
So here also there is distributed focal loss.
Distributed focal loss, is it?
In your epoch, come to the epoch cell output. See, it's tracking that loss, the last of the losses, CLS loss, and then DFL loss.
Uh,
That is focal loss.
where is it written? I can't.
So for each epoch, you will see there are some metrics: box loss, CLS loss.
Oh yeah, yeah, DFL loss. This
Yes,
one,
so the next one is DFL. Yeah, that is focal loss. So that's
focal
where
loss.
I got it from.
Mm-hmm. So they have already incorporated that this thing in the YOLO part.
Yes, sir. That's how we learned about it.
Oh
So I have a question. You're not doing any transformation of the image size, right?
no, this for what, this YOLO V8 this thing?
Yes, sir. For our assignment, do
I
we need
think
to do any transformations? I mean, to be
you
able to identify objects better?
you can do any kind of transformation. I don't think there in the instruction there's some anything written that you can't do any kind of transformation over there.
No, we are using, so even for 9, we have used some transformations.
Yeah, yeah, you can use that.
Okay.
So unless anything is specified particularly that you have to use scratch models or anything like that, you can't use pre-trained model. You are free to choose anything over there.
Okay. And so what is the grading like going to be on? Is it on the score itself or is it
No, so from
overall?
the score we will be checking out like if we can map it to some kind of marks over there. And I
Okay.
think you already know that there are some weightage for this graded assignment and the quiz, this thing,
Right.
end term quizzes and all this. But I think the major weightage is given to the assignment marks, graded assignments as compared to the quizzes and all.
Okay. So in the final quiz, the end term quiz,
Mhm.
we are looking at coding only, or we are looking at some theoretical questions also?
Theoretical question won't be there much because this course is only about practice part, right? So
Okay.
that's why I was saying that someone asked in the G space that if we can use Keras and all. So I told them that specifically to use PyTorch because that will be used in this quizzes and all as well.
Right. For our first two modules, there were a lot of theory questions.
Yep, theory questions will be there. Means theory means you should know what kind of model is there, what are the parameters and all these things. But the focus will be more on the coding aspect as compared to the theory. Whether you
Okay.
can understand those things properly when you are coding it out. Okay.
All right.
Okay. Let me just run this. I think this is as okay. These are the bounding boxes. No such kind. Best.pt. Okay. Contains runs detects its weights.best.pt. So it should have created a best.pt over there, and I think it has not created. Runs detect. What is the train 6? Train 6 waits. There is best of it is already there, but it's not detecting. Contains runs detect the yellow content run detect train 6 waits.pt. Runs and then uh, detect detect then train, only train is there. Only train is there. Okay, train and then waits and then best of it. Okay, fine. We got the bounding boxes over there, and now we will just visualize all those things using Matplotlib. Yeah, okay. It's doing some kind of job. Okay. So here, as you can see, it has detected both as the horse and the person as horse. It has detected the horse and the person distinctively. Here it has not written something else. Okay, here it is detected fox with a confidence of 0.83. Shunk, I think it has also detected something else as well. Okay, yeah. Now the fox here, instead of fox, it has detected it as dog. Okay, yeah. And here, as you can see, it has pointed out the tail of this Shunk as chicken with a 0.88 confidence. Right. Yeah. So here, as you can see, the image is also clear, so it has clearly detected that this is a fox. So this is the advantage of using YOLO. Okay. It has distinctively detected both raccoons. Okay, so let's go down a little bit and okay. Now we have checked this how we can use this YOLO to detect what is there in the picture. Now we will go through whether we can detect the same thing in a video as well. So as you know, video is a series of some kind of pictures or some kind of frames, right? And for this I have a video, so let's just show you that. Yeah, so this is the video, right? So let's see what will happen if I use YOLO to train this model. So this the video name is cat.mp4, and yeah, the object detection animals relate cat mp4, and here you can replace it with the video part. Okay, so now we'll be training this on the we'll be detecting what is there in the video. So as you can see, it is like chunking out all these frames from this video, right? So it is just so there are 294 frames in that video, and for each of this frame, this YOLO model is going to uh, detect what is there in that frame. Okay. I think it is done already. So these things are getting saved over here. So this is a local directory being formed when we are doing any kind of session. And now our task is to like we can just save this data into our own drive as well, right? Okay. Import files, and yeah, we can download this file. So I will be downloading this in my computer, and okay, cat.vlc. Okay, let me just download it in the desktop part. Okay, you can also I don't know this thing will work or not. It was working previously, so let me just check whether it will. I don't think it will run. Anyway, so yeah, so the cat.av3 is here. And let's run this. Okay, yeah, so as you can see, we are able to detect a cat, right? It has detected the percentage of this confidence is pretty high over here. As really it is the confidence going down below 0.5%, sorry, so 0.5 50%. Okay, I don't think it will run anyway. So yeah, so this is pretty much for the week 10, and there is something advanced for this also. This we can, anybody has heard of this name SAM, segment anything model? Okay. So here also this is some kind of object detection, as only you can say, not clearly object detection. It is some kind of object segmentation part, right? Mm, okay, we will just checking out. So if you can variety of input, slash output demo. Okay, I will choose any of this photo over here. So if I click over there, as you can see, it has segmented this dog out of this picture, right? And also if I, okay, do something, everything, it can also cut out what are the objects present over there. It is not particularly for object detection, but more on the object segmentation part. And as you can see, it has pretty much done its job for segmenting out different parts in this image. So this also you can try it out like for different kind of application. So I think they already have this GitHub repo, so you can just download this in your PC or in your Colab, and then from there you can work on your custom data set. Okay, yeah, so that's all for the week 10 part. Any question till this far? Anyone?
So while creating the bounding box, what is the training data that we are giving? It is the images plus we are also giving the bounding box, or is it finding it on its own? I'm like,
So we have already this, okay, let me just go to the training data. So for each image, as you can see, this is the first image, right? We have this bounding box information.
okay,
And
got it.
what is 4 over here? It is the class.
Right. Okay.
So this is also pretty much same of what we'll be doing in the week 10 part, Kaggle competition. Okay. Any question? Okay. Thank you. Then see you all in the next week for the week 11, and yeah, and all the best for the assignment 10, graded assignment 10. Yeah. Thank you. Thank
Thanks a
you.
lot,
Thank you,
Amartya.
sir.
Thank
Thank
you.
you. Thank you.
Good session. Nice session.
Thank you. Thank you.
Thank you.
Okay. Thank you for joining.